In this notebook, I did for experiment 4, which is single layer perceptron. And the first, as usual, I've read the CSV file, which contains Penguin's data set, and it is stored in a data frame, which organizes the data set into rows and columns. This make it easier to manipulate and analyze the data. And for the second question, I have did pre-processing. Before training the model, the data set must be cleaned. For that, I have did mean imputation and label encoding. Mean imputation, if the data set contains any missing values, they are replaced with the mean value of the column. This ensures the data set is complete and usable. And for the second label encoding, the target variable here I use is species. Since species is categorical, mostly the machine learning models requires numerical data. So species names are converted into numerical values. And for the third, I have choose the features. For input feature, I've used bill length, bill depth, clipper length, and body mass, and which are independent variables denoted by X. And Y have used here is species, that is a target variable that the perceptron will predict. And fourth one, I have standardized input features. Mostly these input features may have different scales. For example, the bill length may be around 40 to 60. Body mass may be around 3000 to 6000. So standardization convert all the features to a similar scale with mean 0 and the standard deviation 1. This improves the training performance of the perceptron model. So we converted like that. I have standardized the features. You can see here. And for the fifth question, I have splitted the data into training and testing part. So training used to train the perceptron model, and testing used to evaluate the performance of the trained model. This helps determine how well the model performance on unseen data. Here is the output of the training samples and testing samples. For the sixth question, I have assigned learning rate, number of iteration, initial weights, and bias. So before training the perceptron, several parameters must be defined. So learning rate, which calculates or controls how much the weights change during each update. And for iterations, the number of times the training algorithm runs through the dataset. And for weights, each input feature has a weight that determines its importance. Bias is a constant value added to the weighted sum to the adjust the decision boundary. So initially, weights and bias are set to small values. Here we can see the learning rate is calculated, number of iterations is calculated, and the initial weights. And for the seventh question, I have calculated the updated weight in the every iteration during training. During training, the perceptron calculates a weighted sum of inputs. So output is equal to, it will be in the form W1 X1 plus W2 X2 plus W3 X3 plus W4 X4 plus bias. So the predicted output is compared with the actual output. If the prediction is incorrect, the weights are updated using the perceptron learning rule, which is new weight is equal to old weight plus learning rate into error into input. This process repeats for multiple iteration until the error decreases. Here we can see the iterations become error and it's calculated. And for the eighth question, I have displayed the final weight of the each attribute. After complete the training process, the final weights of all the input features are displayed. Um, for example, body mass may have higher weight than build depth. So as you can see, I have the weight for all the features is displayed on the output. And for the ninth one, I have during training the error is calculated at every iteration. So a graph is plotted, which is x-axis which contains iteration and y-axis which have error values. As the training progresses, the error should gradually decrease. This indicates the model is learning. For the 10th question, I have predicted the class labels. Once the model is trained, it is used to predict the species of the penguins in the test data. The perceptron calculates the weighted sum of the inputs and applies the activation function to determine the predator class. Here we can see the first 10 predictions of calculated are first 10 actual labels. And for the for the 11th question, which is actually last question, to evaluate the model performance, I have did confusion metrics and several metrics are calculated. So a table showing, here you can see a table showing true positives, true negatives, a false positive, false negative. It helps analyze how well the model classifies each class. I have calculated the confusion metrics over here. Accuracy, precision, recall, F1 square to show how the performance metrics for this data set for the model. Thank you.